we talked about similarity. It was back in the first semester. We talked about what makes two figures similar. So as I look at these two rectangles or these two triangles, it tells me that they are similar. What does it mean when two figures are similar? What would be true about these two rectangles or these two triangles? Okay, they have the same angle measures. Okay, if two figures are similar, they have the same angle measures. That's one thing we know. And a second thing we know, their sides are in the same ratio or relationship to one another. Okay, so in some cases that might mean one's 2 times bigger than the other or 3 times bigger than the other, but it's not always a nice whole number either. Like in this case here, when I say going from 3 to 5, adding 2 doesn't work, right? I can't just say I'm going to add 2 to all the sides. That's not going to work. It has to be a multiplier. So getting from 3 to 5 is not a common multiplier. It's not something that we would typically multiply by. So when I talk about the ratio of these two rectangles, they're in the ratio of 3 to 5. Okay? That is a ratio of sides. One side to the other. And you have to compare two sides that are the same. So either it's the two widths or it's the two lengths, whatever it's going to be. Okay? When I compare areas, we don't know the area of the big one, right? That's what we're trying to figure out. Find the area of the one that we're not given. In order to do this, we have to use what we call the area ratio. So the area ratio, whenever I think about area, what do I put on every label of area? Squared units, right? So to get to the area ratio, we're going to take the sides ratio and we're going to square it. And you got to square both numbers. So the area ratio is 9 over 25. So then how we use that is we're going to set up a proportion. So very similar, we did this a little bit in the last chapter. I'm going to say 9 is to 25. We're going to write a ratio of the areas. We know the area of the small one. The area of the small one is 27. We're trying to find the area of the bigger one, right? And so because 9 is smaller than 25, then we're going to put 27 on top, and we're trying to find the area of the big one. So when I set up that ratio, we're going to go small to big, small to big. There's more than one way to set up these ratios, but you got to be really careful about staying in the same order when you do it. Once I have the proportion set up, now we solve it just like we did last chapter or at any point this year. When we have a proportion, we can just cross multiply and solve. And so we get 75. And then label. We've got to do a better job of labeling. Thank you. And so here, if I label centimeter squared. The original area was centimeter squared. So this would be centimeter squared. Okay. Some people yesterday on their test, they just wrote 75. 75 what? Okay. $75, 75 centimeters, 75 inches, 75 what? Tell me what we're labeling. Tell me what we're trying to find. So always put a label when you're doing something like this. Or do a lot of labeling in this chapter as well.
I'm slightly confused because when I did it, I got 45, which is really weird, and I don't know what I did wrong. But comparing it, like 5 divided by 45 equals the same as 3 divided by 27.
Okay, but you can't compare side to area. Right? So there you're trying to compare your side to your area, rather than you got to either compare area and area. that make sense? Like for instance here, let me show you this. I'll just make up an example here. Let's say, probably would be better if I would have used nice whole numbers there. Okay, so first formula, a lot of formulas in this chapter. If you look at your notebook, towards the end of your notebook, and this will be something to refer back to as we go through the next 4 lessons. This is what your chapter 12 formula page is going to look like. I gave you a formula page yesterday for your test. For the quiz next week, we're not taking the test in chapter 12, we're only doing a quiz. This is what your formula page will look like, okay? So you can refer back to this as we go through the next 4 lessons through next week as well. We won't cover all these formulas today, obviously, just a couple of them, but this has all the ones that we're going to do through chapter 12. Okay, there's 2 variables I have to know here. Today we are finding volume. Volume is how much something holds, right? If I took some type of 3-dimensional figure and I poured something into it, water or sand or whatever, I mean if it's a box, I want to fill it up with something, okay? Then what would be the volume of that box or cylinder or sphere or whatever it is we're trying to find? So the first one we're going to do is a prism, okay? A prism is a 3-dimensional rectangular or triangular. It has a base that's a polygon, okay? Some type of polygon. 3-sided, 4-sided, 5-sided, any type of number of sides. The base, that's going to be the part that changes. So that's what big B is going to be. Big B is the area of the base. Okay? And you have to decide what that base is. The base is what I have 2 parallel faces of. A face is a side of a box, basically. We call it the face because we're looking at a side of the box. Typically, your base will be the bottom side, the way it's sitting. Sometimes 3-dimensionals are kind of hard to see. So, for instance, on this one right here, this would have a triangular base. It's the one that I have 2 of, right? The other sides of that are rectangles. If I were to look at a triangular prism, I have an example of one here. This is what a triangular prism looks like, okay? The bases are triangles. That's what we have 2 of. We've got triangle on top, triangle on bottom. The sides of them are rectangles, okay? I don't have a rectangle that looks just like this, okay? Across from it, parallel to it, okay? They're intersecting, but I have 3 different ones. So we don't want these. These would not be the base, because if I set it down like this, you might say, well, now it's the base, but I don't have another one on top of it just like that, okay? So they have to be parallel to one another. The 2 that are parallel to one another are the 2 triangles that sit like that. And that's why I kind of highlighted those 2. So to find the volume of this, we're going to do big B times H. What I typically will do is draw the base. The base here is a triangle. Kind of like we did the other day when we drew the triangles out, but it won't always be a triangle in these cases. Okay, one of the most important things here is you're going to label the sides, okay? The sides of that triangle, and it's kind of hard to see up here, but you see that there's a right angle down here. That right angle is really, really important. Now you're going to have to go back and kind of remember some of the formulas that we did way back when, early in the year, when we did 2-dimensional figures, okay? Right now, I need the area of a triangle. Big B is a triangle. That big B is going to change for every problem that we do. The base is sometimes going to be a triangle, sometimes it's a square, sometimes it's a rectangle, sometimes it's a hexagon. There's going to be a lot of different bases that we're going to look at here. What I'm going to try to get you to do is break it up into two parts. We're going to find the area of big B, which is a triangle, and then we're going to multiply it by its height. I like to set it up in two separate parentheses so you can kind of see what's what here. How do I find the area of a triangle? What's the formula for area of a triangle? Yeah?
Base times height divided by 2.
Base times height divided by 2. Okay, now here's where it gets a little bit tricky. Base times height divided by 2 is what we've always talked about. But this is talking about the height of the triangle, not of the entire figure. The height of the triangle would be these two pieces here. So there's two different heights in this particular problem. Because this was a right angle, I can just do 4 times 3 divided by 12 because those two are perpendicular to one another, and when we have a height, it has to be the perpendicular height. So that's 4 times 3 divided by 2. That gives me the area of the triangle, of the base. Now this is the height of the prism. The height of the prism is this guy right here, okay? How far is it from base to base? How tall is that prism, the height of it? So this would be 2. And I'm putting it in a different color so you can kind of see the different heights that we're talking about. The triangle height and the prism height are two different heights. That's easily confused because we're still talking about height. So 4 times 3 is 12. 12 divided by 2 would be 6. And then we take 6 times 2. Labels for today, we're talking about volume. Volume is cubic centimeters. The reason we call it cubic is because we're now in 3 dimensions, right? And so we have length, we have width, we have height. And so we have 3 dimensions. And so all of our volume labels will always be cubic. Area is always squared. Volume is always cubed. Okay, over here. I'm going to highlight the base here, okay? The base is a figure we haven't seen for a while. What kind of figure is the base here? It's a trapezoid. Okay. So we have to find the area of a trapezoid. Okay. And so when I write this out, volume equals big B times H. Okay, the height of this from base to base has to be a perpendicular height. So that's why it's drawing it out. This is what we call an oblique prism because it's kind of slanted. The sides aren't upright. They're not straight up and down. So they're kind of slanted, right? But this is the perpendicular height from base to base. So 5 is the height of this prism. So 5 is going to go right here. That's the height of that trapezoidal prism. It's kind of a weird shaped prism. What we have to remember is how to find the area of a trapezoid. It's not something we've done for a while. We talked about it way back in first semester. And so that's one of those formulas that we got to remember. The area of a trapezoid is 1/2 times the height times B1 plus B2. Okay? But once again, this is the height of the trapezoid. That's why I'm trying to separate this out. And then this are my two bases. So for instance, on this one, the height of that trapezoid, the 3 is pointing to the height of that trapezoid, so that's 3 right there, okay? The bottom side is 14, whichever side you want to call the bottom, okay? One side is 14, the other side is 6. These are my two bases. Doesn't matter which one's which, okay? I could call this one base 1 and this one base 2, or vice versa. Doesn't matter which one you call base 1 and base 2. So when we type all of this in to our formula, we're going to do 1/2 times the height of the trapezoid, just the trapezoid, okay? I'm writing all this out. The reason I'm writing all this out is because you have to do things in a particular order. Order of operations is extremely, extremely important. Okay, if you just try to do this whole thing in your calculator without writing it out, there's a pretty good chance you're going to miss it. I'm just giving you a fair warning, okay? You try to get in a hurry and you just try to type all of this into your calculator. If you don't write it out, then you're really going to struggle with what's going on here. What I would do over here is do all of this first, right? Order of operations. So here we have parentheses within parentheses. So here I'm going to do the parentheses inside the parentheses first. 14 plus 6 is 20. 20 times 3 would be 60 divided by 2. This whole parenthesis becomes 30. My height of the prism is still 5. Okay? But you got to break it up into smaller parts. Don't try to do too much. Don't try to do it without writing it out. And then it's always cubic centimeters. So you're going to see a lot of different types of prisms today. That's just 2 examples, okay? My bases are going to change. That's what you got to be able to identify. That's why we kind of gave you a weird one, the trapezoid, because we have a big one and we have a small one. Let's say this is in the ratio of, I'll give you the big one. Big one's 6 and small one's 4, okay? If I know that this one is 8, okay, then my ratio is in the length of 6 to 4, okay? So 6 over 4 would reduce to be 3 over 2. That would be my ratio. To find out what this side length would be, I could set up a ratio with that. I could say 3 is to 2 as 8 is to x. So if I cross multiplied here, I get x equals 16 over 3. Okay. But to find the area of both of these, I would have to take length times width. This would be 48, and this would be 64/3. Okay, so they're in different ratios. So that's why you can't just compare like a side to like an area. Okay, that's where you got to be careful on that. It's not all going to be nice triangles or rectangles or things that we're familiar with seeing. A trapezoidal prism is not one we typically see, but it is still a prism. Okay, the next one we're going to talk about is a cylinder. Okay, cylinder is another figure that we've seen before. We've talked about it before. Okay, we want to find the volume of this cylinder, and the first thing I'm going to tell you is the formula is the same. Big B times H. But when I have a cylinder, what type of base do I have? What is the base of a cylinder? Circle, okay? Big B is a circle. So for a cylinder, it's always a circle. Your base isn't going to change. It's not like this time it's a triangle and this time it's a trapezoid and then a square. A cylinder is always a circle. So that's the nice thing about cylinders. They're not going to change. the size of your circle is going to change. And so knowing that, because the base is a circle, we just got done talking about the area of a circle, right? We're going to find the area of big B. Well, the area of a circle is pi r squared. So instead of doing big B times h, we're going to do pi r squared times h, because that is big B. This time it's the same every time. I still kind of like to break it up into parts. Pi r squared times height. So we're putting the numbers in the right spots, and you can kind of see where everything goes. So over here, this would be pi times 9 squared, and my height would be 6. So this one's pretty straightforward. Okay? We know the radius, we know the height. It's just a plug and chug. I did see some instances of struggling with calculator yesterday. Some people had the right work written out, and then for some reason we just weren't putting into our calculator correctly. Okay, so if you're not getting the right answers in your calculator, that's why we got to practice these things. Okay, I can't tell you how to plug it into your calculator because your calculator is different than everybody else's calculator, right? There's not just going to be this sequence of numbers. This is how I plug it in. And so that's why I don't tell you how to plug it into the calculator. But I tell you, if you have questions on how to plug it in, ask. This one, we should be able to just plug it right in to our calculator. Pi times 9 squared times 6. Now, I will tell you this. There's two ways to write your answer. Sometimes they're going to write our answer in terms of pi. So if I write my answer in terms of pi, then I'm going to do 9 squared times 6. So 81 times 6. That would be my answer in what we call terms of pi. That would be like our exact answer. Okay? Sometimes we leave an answer like that. If it ever says write your answer in terms of pi, that's how I write it. And then I put a label on it, bless you, and then I'm done. But if they ask us to write our answer rounded to the nearest 10th or 100th, whatever place we're going to round to. Yesterday we rounded to the nearest 100th the whole time on the test. So let's do that again. If we put that into our calculator, once again, I would make sure that you're using your pi button. You have a pi button on your calculator. I don't know of any calculators that don't have a pi button anymore. If you don't think you do, let me know and I can see if I can find it. But you should be don't be using 3.14. Okay, that's just an approximation for pi. Okay, this one is kind of the same idea. Except this is what we call an oblique prism, an oblique cylinder prism, because it's slanted. That's why the height is drawn out here to the side, because we have to have a perpendicular height. So we're going to go volume equals pi times 4 squared times 7. If we write our answer in terms of pi, we have 112 pi. If we go ahead and round it to the nearest 100th, we should get that. Okay. Practice putting those into your calculator. We've been doing things with pi already. We had a lot of questions that had pi on it in the last chapter, so that's not something that should be new. But if you haven't been doing that or haven't been practicing that, make sure you get that practiced out. Okay, let's look at this one here. Okay, what type of figure do we have right here? Is it a cylinder? No, my base is not a circle, right? So this is not pi r squared times h. So we got to always pay attention to what is our base. Our base here is what kind of figure? Triangle. Yep, triangular prism. Okay, that's what we have two of. Okay, the base here is a right triangle. It has a base of 9 and a height of 5. I have to find the area of this base. That's why I like to redraw it. That's why I like to separate it out, because I got to find the area of big B. The base is big B, whatever that figure is. That's going to be the hard part to these problems. Your base is going to change from problem to problem. We already talked about the formula. And then the height of the prism is 8. So 9 times 5 divided by 2 gives me the area of the base. And then if I multiply that by 8, what do we get? Yep. 180 meters cubed. Okay, I don't think there's any reason to do the next two. They're very similar to the two we did at the top. They're just some more cylinders again. There's nothing special about those two, nothing different about those two. So it's just plugging it in and getting those. Okay, here we have this rectangular box, this chest. And it gives me 2 out of the 3 dimensions. We don't know the height. Okay, so once again, we're going to use the same formula. Big B times H. In this case, big B is a rectangle. The base of that chest is a rectangle. It's 6 by 4, okay? And we know that because it tells us that. It's a rectangular chest, which means the base is a chest. We always name a prism based off its base. Triangular prism, rectangular prism, hexagonal prism, whatever the base is. How do I find the area of a rectangle?
Base times height.
Base times height, length times width, however you want to call it, okay? We don't know H, that's the height, that's what we're trying to find. They do give us the volume. The volume is 72. So this is just a solve backwards type of question. 6 times 4 is 24. So that would be 24H. And then it's just one step equation. 72 divided by 24 gives me 3 feet. Okay, I probably should label it. Okay, the second one here doesn't give us a picture, but it's kind of the same idea. This is my length. This is my width. We're trying to find the height. So we're going to say 30 equals length times width times the height. Okay, you might have seen this before. When you did volume of a prism way back when, probably in middle school, you probably saw this formula. Volume equals length times width times height. That's only for a rectangular prism, and that's because the area of a rectangle is length times width. Here we're just separating them out. Here's the base, here's the height. Because when you did it back in 8th grade, you didn't have all these other bases. You didn't have a hexagon base and a trapezoidal base and all the different types of bases that we could now have. You just had either a rectangle or maybe a circle, maybe a square, some of your basic figures. So this would be 5 times 2 is 10, and 30 divided by 10 happens to be 3 again. Okay, this one's a little bit different question. So you just got to read these carefully. Once again, it's a rectangular chest. So as long as it's rectangular, then volume equals length times width, which is my big B, times the height. They tell us the volume is 25. We don't know the length or the width, but we know the height is 2.5. Okay? What you got to remember here is length times width is also what we call big B. Big B is the area of the base. And that's what it's asking me to find right here. We're looking for big B. So all I got to do here is take 25 divided by 2.5. Now here's what makes this one a little bit different. We're finding the area of a base. How do I label area? Square units, okay? So this would be feet squared because you're taking two different units, length times width, and multiplying them together. Length times width would be squared. So base is 10 feet squared. The area of that rectangle is essentially what we're saying. Okay, last question here. We'll see. If we need to do another one, we will. We've got two of these, but I think one of them should be enough. See if you guys get the hang of it. Okay, this goes back to the very first problem that we did. That's why we did that warm-up question. At the beginning of the year, when we talked about area, we did area ratios, and that's what that warm-up problem was going over. So simply here, you have three different ratios. We have what we call the similarity ratio. Similarity ratio is also the same as the sides. Okay, similarity is the ratio of the sides. I can do any sides. I could do length, I could do width, I could do height, I could do radius, I could do diameter, any type of length of some type of measurement of that figure. In this case, we have a circle. So we don't have base and height, right? We have a radius. So when I write my similarity ratio here, it would be 3:6. You got to compare two pieces. It could be the two heights, it could be the two radii, it could be the two diameters. In this case, it's the two radii. Always reduce it. So if I reduce it, I get 1:2. Okay? Which essentially is saying this cylinder is 2 times bigger than this cylinder. That's all we're saying here. Okay? When I compare the areas, we have to take that ratio and square it. So that would be 1:4. Okay? So what that means is the area of this, like if I wanted to cover this with paper or something like that, the surface area is how much area needs to be covered. Then this is going to take 4 times as much paper than this one if I were to wrap it up or something. Okay? So the area is 4 times bigger. The volume is always cubed. So we're going to take that same ratio and we're going to cube it. Okay? What that's telling me is this cylinder is going to hold 8 times as much water as this cylinder. Okay? That's why we can't just compare the sides. It's 8 times bigger, or it holds 8 times as much, I should say. Not necessarily 8 times bigger, but holds 8 times as much whatever we're going to put into it. Water is a really good idea of something because it fills up the whole space. So those are my 3 ratios. Okay, here's how that works. It's asking me to find the surface area and the volume of these solids. Okay, so first up, if I wanted to find surface area, the key here is that it is area, right? Surface area. Keyword is area. So we're going to do 1/4 because it's an area ratio. So we're going to do area. 1/4 equals, they give me the surface area of the smaller one, right? We want to find the surface area of the big guy. So 48 pi is smaller down here, 1 is smaller than 4, so 48 pi goes on top. We're trying to find the area of the big one, so that's my x. Okay, and I'm going to show you a little bit of a trick here, okay? You do not need to multiply by pi. I'm just going to write my answer in terms of pi. So when I cross multiply here, all I'm going to multiply is 48 times 4. And then I just put pi on my answer. There's no reason to divide by 1 because dividing by 1 doesn't change anything. So 192 pi centimeters squared because it's area. Okay, if I'm going to do volume, I do the exact same thing, except I'm going to use the volume ratio. So you have to use 1/8. Because we're trying to compare volumes. Okay, 1/8. The volume of the small one is 45 pi. And we're trying to find x. So once again, we cross multiply. 45 times 8 is 360 pi. And then this is volume, so it's cubic centimeters. Okay, I'm not going to do all of the next one, but if I just to do this one more time, anytime you do a problem like this, we're going to do similarity, area, and volume. When I write my similarity ratio, I'm going to compare any two sides, but they have to be the same side on both boxes. The only side I know for these two boxes is 12:3. So my similarity ratio here is 12:3. If I reduce that, it would be 4:1. Would it be okay if I wrote 1:4 and went small to big? Sure. Okay. It doesn't say you have to go from the big one to the small one or vice versa. 1:4 or 4:1, either one is okay. The area ratio would be 16:1 because you got to square both of those numbers. The volume ratio would be 64:1 because you got to cube them both. Okay. And then you could set up your proportions from there. But you got to find the ratios first. Okay. I haven't added big ideas yet. I need to do that real quick. So we'll add 12 two big ideas and then let you go. I did get your test put in, so just keep in mind if you want to, that's the last chapter test of the semester. So if you want to retake that test, you have all next week to do that. You just need to come in sometime next week, and I'll be glad to go through it with you and you can retake it. Next week we have a quiz on Friday, and then that'll be our last grade before it's final. Where your grade's sitting at right now is pretty much where your grade's going to be at. Your quiz may change it just a little bit, but because we have so many quiz grades in the grade book right now, don't expect it to change a ton. So that's why retaking your test is going to be your best option if you want to try to get your grade up a little bit before finals. Okay, should be up now for you. Really just pay attention to what your base is. That's going to be the biggest thing you have to watch for on these problems.